Hi again, welcome to the video applying the important trig relationships in the previous video to simplify and prove things we encounter in our analyses. This video will help you consolidate the results from the previous video by applying them to parts of real contexts involving trigonometry. In this video there are two types of questions: simplify expressions and proving relationships. We've discussed various results in the video on trigonometric relationships. You've got to remember those well, and we now have practice in applying those results. Now, the general approach to all of the identities, 99.99% of them anyway. Start with the most complicated side when you're proving the identities. Don't change terms between the sides. Second, if there are any complementary angles, the 90 minuses or the 180 pluses even for the supplementaries and so forth, then change them to the normal ratios. Get rid of them quickly. Thirdly, if you see sine squareds or cos squareds or cot squareds and so forth, then apply your Pythagorean identities immediately up to this point. Fourthly, very important, we're not going to use tans and coses and secs and so forth. We're going to change all tan and reciprocal terms to sines and cos. It makes it so much easier for you and quicker. And fifthly, like in a lot of maths we do, we have to cheat a bit. So have a look at where you have to go, what you have to prove, and you obtain hints about what your possible approach might be. Be smart. So for example 1, we have to simplify sec x times the square root of 1 minus sine squared x. First step, sec x, we don't want it. Put it to a 1 over cos x with a reciprocal relationship. In terms of the square roots, we know we've got a Pythagorean identity there, and we can replace the 1 minus sine squared with a cos squared x. Rewrite the 1 over cos x, take the square root of cos squared x, we have a cos x. The cos x's cancel, we're left with a 1. Example 2, we have to simplify sine x over 1 plus cos x plus sine x over 1 minus cos x. We look at the denominators, look ahead, and 1 plus cos, 1 minus cos, obviously a difference between two squares, so we fill in our denominator to start with, multiplying those two together to get a common denominator of 1 minus cos squared x. Now we cross multiply, so sine x times 1 minus cos x gives us sine x minus sine x cos x, and then we go the other way, so that sine x times 1 is sine x plus sine x cos x. Those two terms cancel out, sine x cos x, so we're left with 2 sine x on the top and a sine squared x in the denominator. One of the sine x's cancel, so we're left with a 2 over sine x, which we can rewrite as a 2 cosec x. Third example, simplify 1 minus sec squared times cosec squared minus 1. Both of these are Pythagorean relationships. So 1 minus sec squared is actually minus tan squared. So we put that down, and cosec squared minus 1 is straightforward, that's just cot squared. Now get rid of the cot. We'll leave the tan there for now, but it's minus tan squared x times 1 over tan squared x. They cancel out, leaving us with minus 1. In terms of our complementary angles and angles of any magnitude, we might have to simplify cos 90 minus theta over sine 180 plus theta. Well, we know that cos 90 minus theta is equal to sine theta, and for the sine 180 plus theta from our angles of any magnitude, that's in the third quadrant, so sine is negative, so we're going to write minus sine theta, and they cancel out to give us minus 1. So now we move on to proving things. We have to prove that 1 over cos beta minus cos beta is equal to tan beta times sine beta. Well, the left-hand side is a little bit more complicated because it's got the fraction, so we'll start with that, left-hand side equals. Bring it to a common denominator by multiplying through by the cos beta, so we've got 1 minus cos squared beta over cos beta, and now we've got a Pythagorean relationship in the numerator, which we can exchange for sine squared beta. So now take one of the sines, and we have sine over cos, which is tan, and we're still left with a sine in the numerator, so we just put that down. So it's equal to tan beta times sine beta, which is the right hand side. Next example is to prove that tan x over sec x minus 1 equals sec x plus 1 over tan x. Important in for step 5 here. Look where you're going to go. How are we going to get that sec x plus 1 in the top? Well, just like when we rationalise irrationals, fractions, then we could multiply top and bottom by the conjugate. So write down tan x over sec x minus 1 for the left hand side and multiply top and bottom by sec x plus 1 over sec x plus 1. Multiply the two numerator terms together, so we've got tan x bracket sec x plus 1, and the denominators go to sec squared x minus 1, which is a Pythagorean relationship, so we can replace the denominator with tan squared x. So one of the tans in the tan in the numerator goes out with one of the tans in the denominator, leaving us with sec x plus 1 over tan x, which is where we wanted to go, so it's equal to the right hand side. Final example is to prove that tan theta over sine theta minus cos theta is equal to tan theta sine theta. Well, left hand side's got the fraction, so we'll start with that. Left hand side equals sine theta over cos theta, because we're going to replace the tan with sine over cos. And then we've still got the sine theta in the denominator, so write that down, minus the cos theta. Now the sine thetas cancel, we're left with 1 over cos theta minus cos theta, which is what we had a little while ago actually. And so bring us a common denominator, 1 minus cos squared theta over cos theta by multiplying through, equals the Pythagorean relationship, so the 1 minus cos squared is replaced with sine squared. We'll take one of the sines. Sine over cos is tan theta. We've still got a sine in the numerator, so it's write that down. That's what we wanted. It's on the right hand side. Excellent. So there you have it. Trig identities are fun and generally not too hard. You must know your relationships as described. Take the 5 points in blue from the left hand side of the screen that we've been using and put them into your study notes. Go and do Test Yourself 1 on my website, drjsmaths.com. Thanks for watching this video. Hit the like button and subscribe if you haven't already. Good luck. See you later.